Jakub is, he has a master's degree in quantitative economic analysis, and he is also, so to say, a well-practiced practitioner in the area of time series analysis. He has multiple years of experiences in various projects and also in terms of time series at scale. So he worked quite a few years for Philip Morris International, and also is currently a lead data scientist at Linger. And yeah, super looking forward to the talk today. Today, Jakub will share his insights about the winning strategy, actually, because Jakub recently won one part of the VN1 time series forecasting competition. That is, or was, competition, as the name suggests, about time series forecasting, named by Nicolas van der Put. Maybe one person or the other knows him. Super interesting problem, super interesting competition. And Jakub, we are glad to have you and looking forward to hearing about your approach. Give a warm applause to Jakub. And stage is yours.
Thank you. Thank you very much. Thank you very much. I'm very happy to be here. So I'll start sharing my screen and let's talk about. So you should be able to see right now my presentation, right? Great. All right. So the topic for today is about VN1 Forecasting Competition, and I want to guide you through my entire thought process and my submission process. And also I want to guide you through this question: how to win a forecasting competition several hours. So my name is Jakub, and I'm a data scientist at Lingaro, and where I help companies to build advanced forecasting solutions. And recently, together with Philips Labs, we won VN1 Forecasting Competition as the Zero CRM team. And we use an ensemble of LightGBM and AMSI and Starima. And today, I want to focus on my side of the journey. So particularly focus on my LightGBM approach and method. And huge shout out and credits to Philip. He is a great guy, very experienced and smart. So credits to him. I wouldn't be here without him today. Also, thank you for the sponsors. VN1 was organized by Nicolas van der Put, sponsors Fleaber, Syrup, Subchains, and it was hosted on datasource.ai. So the goal of the competition was to accurately forecast more than 50,000 unique products. And it was real world e-commerce data. The forecast horizon was 13 weeks, and the evaluation metrics was called Z-score, which was the combination of mean absolute error percentage plus absolute bias. I like this metric, to be honest, because it addressed two things. First of all, average absolute error week by week, but also this cumulative error on the entire quarter. So the data available was historical sales and prices, and the competition was structured in two phases. So phase one was to forecast Christmas quarter sales, and the leaderboard was available for all 218 competitors. And in phase two, it was about to forecast post-New Year period, post-New Year quarter sales, and the leaderboard was actually unavailable. So it was imitating this real-life scenario where you needed to pick the best model and forecast it without any hint how well your model is performing or not. So let's take a look at the data to better understand the goal of the competition. What you see right now on the chart is a sales aggregated for all products. So it's just total sales. And also what you can see on the screen is phase one objective and phase two objective. So to better visualize it for you, in phase one, you could use the gray line, so the gray part of the data set to forecast the blue line. So in total, it was around 2.6 million observations that you could use to forecast 200,000 observations during the Christmas period. So in phase two, phase one objective became actually part of the training set, and that made it to 2.8 million observations in the training set that could be used to forecast the next 200,000 observations. So coming back to the main point, how to win in several hours. From now on, I want to guide you like step by step through my entire thought process and submission process. So my submission process was containing those three steps, and it was iterative process. So exploratory data analysis, modeling and feature engineering, and then evaluation and error analytics. So exploratory data analysis helped me to uncover some crucial patterns, and I will show you now what decisions it allowed me to make and what hypothesis it brings to me, so I could use that in my modeling. So this was literally the first chat that I've done. So I just initially loaded the data, did some small pre-processing, and that was the first chart that I actually plotted. So the total sales. And just the first glimpse at it helped me to understand three things. So first of all, multiplicative seasonality is visible. So each year there's a seasonal pattern, which is actually growing year by year. So my hypothesis was that, yes, there is some kind of multiplicative seasonality here. And the next year, potentially, it will be also growing. Another one that caught my attention was the higher volatility observed lately. So clearly something changed in this time series process. And very often in this fast growing e-commerce businesses, the older data is not representative anymore because the business is growing very fast. So that also caught my attention. And another one which was clearly visible were those outliers. So with those three observations, multiplicative seasonality, higher volatility, and outliers, I made my first decision. And it was that I'm going for tree-based models, and specifically for light GBM, because it's very fast, so it's crucial while working under time constraints. It can handle complex nonlinear relationships like multiplicative seasonality, assuming that you do a proper feature engineering. It's a global model that can learn interdependencies between similar products, which was the case because we had some kind of hierarchy in the data. And it's quite flexible and responsive. So usually it's robust to outliers and insensitive to variance changes. Coming back here about higher volatility observed lately. So another thing that came to my mind that I need to be cautious with cross-validation here. Because clearly something changed in the latest data dynamics. So variance increased lately. So I made the decision that I will create a threefold cross-validation architecture here. The freshest data was the most important in my evaluation process. But I also wanted to evaluate my model, how well it is able to capture the seasonal patterns. So I was observing this CV1, which was the same period last year as objective for phase one. So in conclusion, just taking a quick look at this total sales helped me to decide about the main model and the cross-validation architecture. And from now on, the next steps was to conduct a detailed exploratory data analysis to gain the deeper understanding of the dataset characteristics. And I work with time series data pretty often, and I have a range of techniques and pre-written functions at my disposal for conducting comprehensive exploratory data analysis. So I want to name a few useful techniques that I'm using whenever needed. So for example, if you have a lot of time series, most likely you will not be able to plot all of them. But plotting some random subset of time series across various hierarchies can give you already a good glimpse about the nature of your data set. Also, ranking some products based on, for example, coefficient of variation, partial autocorrelation functions with seasonal lags to capture multiple seasonality patterns, contribution of outliers calculated, for example, based on rolling z-scores, trend and seasonality strengths. Also, heat maps is a very useful tool whenever you need to plot large amount of time series, and you can highlight there some missing values, outliers, or low sales. So let's talk a little about this random sample plotting. And here, what you see on the screen right now is the sales data aggregated at the warehouse level for 9 randomly selected warehouses. So here, for example, it's clearly visible that for one warehouse, something changed in time series dynamic lately. So it became way more volatile, and potentially adding some rolling standard deviations could help the model to more accurately forecast this period. Now, looking at the product aggregated sales, there are some time series with non-linear short and long-term trend lines. This product, for example, is quite flattish, but if you take a look at shorter term trend lines, well, it's changing. So potentially adding some rolling averages with long and short windows can help to model better this type of product. There are some seasonal products also visible here. So seasonal rolling features might be a way to go. And there are also some products with intermittent demand. So using 2D distribution seems reasonable here. And from now on, I performed multiple iterations and experiments. So I was adding a new features, tweaking model parameters, and I was also evaluating the results to refine the approach. And my feature engineering was a direct extension of this EDA findings. So whenever I detected multiple seasonalities, I addressed that with seasonal rolling features with different different windows, sorry. Whenever I saw some level shift during long promotions, I added price momentum growth rates, some client-specific patterns, client encoding. And I talked a lot about EDA and feature engineering. So now I want to focus on evaluation and error analytics. So forecasting evaluation for me is a game of relatives. And this well-designed benchmarking is essential for selecting an appropriate model. And just to remind, the competition metric was z-score, so mean absolute error in percent plus absolute bias in percents. So I was benchmarking my new challenger model versus previous champion model and versus less complex methods. So like naive, ETS, and theta. And this was to understand what new challenger model forecast value added. Is it actually performing better or not? And for the freshest data got more weight in this cross-validation architecture. And again, to visualize it, fault 3, 75% of the weights, fault 2, 15% of the weights, and fault 3, 10% of the weights. And to better assess model forecast, I was also visually inspecting its performance on cross-validation sets. So here you can see a comparison of two models, one using rolling seasonal features, another not. So clearly this orange line is actually capturing the seasonal patterns way better than the green one. So few conclusions after phase one. Modeling and feature engineering was a direct extension of my EDA findings. This thoughtful feature engineering can significantly improve the accuracy. And you can see also on the screen right now, the final recursive model properties. I was performing some manual tuning, so because I had no time, and there is clearly a room for improvement here. Hyperparametric tuning would be a way to go for sure. And I built this tree with those parameters and small regularization. I also used some features like rolling features, averages, median, standard deviations, maximum, minimums, seasonal rolling features, lags, price growth rates, and calendar features. What worked and what did not work? I will not go through this entire list, but just to name a few, what worked was adding a price and price momentum, and that was expected, and adding many seasonal features to capture multiple seasonalities. And what did not work was the target transformations. So for example, differencing, some log transforming, squaring. I was experimenting a little bit with this kind of transformations. Sometimes it works, sometimes it's not. Here it was not the case. And what did not work and was surprising a little bit for me was custom objective metric. Because in the competition, we were using this D-score. So I was also trying to use that as one of the objective functions for LightGBM model, but that did not work. So final conclusions here, the entire process took me less than 6 hours, and I submitted the model, and initially I got ranked in top 10. I think it was 8th place. And I decided not to continue. I knew that this model had a room for improvement because it was a little bit under forecasting due to the fact that I was optimizing it on mean absolute error. But I was on the vacation, so I decided not to do that. And I posted on LinkedIn that I was done, and I wished others good luck. And later, I received a message from Philip suggesting me to collaborate and try an Ensemble. And this is where the party actually started. So we submitted an ensemble with following weights: 45% for LightGBM, 30% for Sarima, and 25% for AMSI. And it was the result of few iterations. And that was, I wouldn't say that was the most optimal weighting, to be honest, because we didn't perform any optimization methods here, but it was actually proven to be quite robust because in the end, we submitted the same weights for the final submission. So it was completely different window, and actually it was still performing very good. We also performed some actuals and forecast analysis to ensure this reliability, if it makes sense, just visually inspecting client by client, for example. We treated some outliers, and we also applied some forecast smoothing. And this is how we won. So, and how we improved the accuracy over 30% versus competition benchmark, which was moving average. And by the way, the fun fact, based on post-competition analysis by Philip, an alternative combo with 75% of LightGBM and 25% of AMSI would give us even a better score. And my solo single LightGBM 3 would put me on the second place, right after Justin, which was, I think it's a good score for a single tree. So to the main point, how to win a forecasting competition in several hours. Exploratory data analysis first, so understanding the problem, thoughtful modeling, and ensemble of people and models. And for me, the best is to have an ensemble of people and models. Thank you very much.
Thanks a lot, Jakub. Very cool. I have two a bit technical questions.
Sure.
And that is, why did you choose a recursive approach and not a multi-output? And the second is, did you try very hard to confine the number of features? And I guess the answer is yes, but I would be interested kind of in your perspective and maybe also kind of just the number of features that you used just as reference and why, yeah, and why so? I mean, why you tried to restrict it in case you did?
Yeah, so regarding the recursive approach, I was using Nixla library, which I'm a big fan of. So recursive approach there is a default approach. So basically, it was the easiest way to go because I was using this library, and because it was a default setting, I went for recursive approach. Also, this recursive approach is a way to go for me usually because whenever you try the direct forecasting, you need to train multiple models, and there is a risk because you have more models, of course. So in production environment, this can cause some problems, and this can cause some complexity. So I'm always starting with the recursive approach, as it's way easier to maintain. And if you use libraries like Nixla, it's a default setting. And regarding feature engineering, so I was building my model from the very simple setup of features. So I just used the lags. And then it was an iterative process. So I was going and I was visualizing my data. And then I was adding any features based on my hypothesis observed from the dataset nature. So I saw some seasonality. I was carefully adding seasonal features and performing few iterations to find the ones that are actually performing the best. Then I observed some price correlations. I was adding carefully one by one the price features. So in that scenario, when you build your model iteratively and adding these features like one by one, in the end, you only include the features that are actually most likely important. And this was my process. In the end, some feature analysis and, for example, reducing the dimensions is usually the next step. To be honest, I had no time here to play with some, for example, recursive feature elimination or things like that.
Cool, thanks a lot.
All right, thanks for the presentation. So I was wondering, let us assume that you were giving a month instead of a couple of hours. How would you tackle that problem? And let's say, have you a change strategy?
So what I would do, I would definitely experiment with other models. So in phase 2, I had some time to experiment with other trees like CatBoost and also XGBoost, and the results were promising. Why it was not included in the end, because it was risky and due to lack of time. So for sure, I would add more models to the picture and try different, more complex methods. And definitely some more feature selection methods. And this is also regarding previous question. I was adding some regularization, but it's not ideal. So usually some more thoughtful feature selection methods can bring more value and can also ensure that the model is not overfitting. I saw that the model had a tendency to capture a little bit of the noise. This is why we performed the smoothing. So it was very ad hoc thing to do to smooth a little bit out the noise. So definitely addressing the overfitting, adding more models to the picture would be something that I would consider to do here. Yes.
Okay, we have another one.
Okay, me again. So if there's someone else, I would give precedence, of course. Else, I would come back and ask 2 follow-up questions to pick your brain a bit on multi-output and large GBM again, or kind of a recursive and large GBM. And I understand this is kind of your go-to approach, and that sounds very reasonable. But from your experience, do you see a performance difference between multi-output and recursive? Let's just say there's no human time constraint, so to say. I mean, 6 hours, yes, not that much. If it's only about performance. And the second one, can you elaborate a bit on why LightGBM other than speed, especially comparing with the other popular Cat Boost and XGBoost?
Yeah, so regarding the multi-step forecasting and adding more models, when I perform some experiments and when I perform some experiment on the real, and also working on the real life data, adding more models is beneficial. That's my observations. But yeah, it can introduce the training cost. It can introduce some maintenance issues on the production. So it always depends on the dataset nature, and it always depends how crucial it is to improve these few points of accuracy. Because if in the end it can affect the reliability of entire production pipeline, just to improve the score by not that much, I would like to avoid it. But if the accuracy is very crucial, the multi-step forecasting, based on my observations, can be more beneficial than the recursive one. And why LightGBM? To elaborate a little bit more, well, I know that there is this this big discussion which model is better, and I think based on some research papers, the Cat Boost is actually outperforming XGBoost and LightGBM. And to me, usually the differences between those models on a sufficient data sets are marginal. So whatever model you use on a sufficient data set with a signal, most likely you can count for only few points of extra accuracy. So I'm going for LightGBM personally because it's fast, and also I feel this model, and I know this model the most out of all the trees that are available.
Makes sense. Thanks a lot for your assessment.
We have one question from online, which I would like to just read it, Jakub, because I'm not sure if you can actually see it. The question is from an anonymous attendee. Can you explain the form, that is formula to compute, of the feature price momentum? And what did you use as price and price momentum during the prediction period? For example, were you using the average price as the assumed future price?
So I was assuming, because the future price was not available, so I was assuming that the price will stay constant, forward filling it. And regarding the price momentum, how I was calculating it, I was using some rolling averages of the price. And then, for example, when I used the rolling average price with a window 4, I was calculating the growth rates with the current point versus four periods ago. So those gave me the understanding what's the latest price momentum. Is it growing on average or not? Is it decreasing? And this helped the model to be a little bit more sticky whenever I saw, whenever there were some products with longer promotion shifts clearly visible.
Okay, thank you. Is there any other question from on site? Okay, if that's not the case, then let's thank the speaker again. Thanks a lot, Jakub.
Thank you very much. It was a pleasure. Thank you for giving me platform to talk about this competition. I wish I was there. So have fun. Thank you very much.